Hey guys, and welcome to our flipped video lesson on Unit 1, Target 6. We got a lot to cover today, so let's get right into it. Talking about number sets. Well, how many numbers are there in all of existence? Hopefully you said infinity, right? There's a cool bridge there, kind of looks like an infinity sign, right? And the problem we have with that is when you have an infinite amount of something, and heck, even if you don't have an infinite amount, but just a ton of something, it's really hard to work with it unless you have it organized. And that's what our number sets do, is they take the infinite amount of numbers we have in all of existence that we could come up with, and they organize them into sets or into groups so that we can work with them easier and talk about them easier. Now, to understand how the number sets relate to each other, it's easy to understand that based on an analogy with geographic location, right? So let's just say you're at school, you are currently located in Grayslake, Illinois. Well, if you're in Grayslake, you're also in Lake County. If you're in Lake County, you're also in Illinois. If you're in Illinois, you're in the United States, and if you're in the United States, you are on planet Earth. Notice how each smaller geographic location fits into the larger one. And if you're in a smaller one, you're guaranteed to also be in the larger one. But the reverse is not true. Just because I live in the state of Illinois does not mean that I am located in Grayslake. But here's the deal with planet Earth, is United States is not the only place in planet Earth where you could be. There's lots of other countries. Let's just say Australia is another option. So there are going to be times where you might not be in any of those locations that are linked together. So hopefully we're going to use this analogy of the way these geographic locations link together to kind of help us understand how the number sets relate to each other. So let's get right on the number sets here. First number set is the natural numbers. These are our counting numbers. Start at 1, count to infinity, no negatives, no fractions, no decimals, and no zero. That's like Grayslake. Whole numbers. They're natural numbers and zero. So it's almost exactly the same as the natural numbers, but we just add one more number to the set. This is like Lake County. Integers. The natural numbers, they're additive inverses and zero. So now notice we're from 1 to infinity, 0, and from -1 going to the left to negative infinity. But notice we still have no fractions and no decimals. This brings us to the rational numbers. These are numbers which can be written as fractions. This is like the United States here. This contains all of our previous number sets. Now, numbers that can be written as fractions can be actually a fraction, such as 5 can be 5 over 1, -3 could be -9 over 3. So we know that those can be written as fractions. But what about decimals? How do we know which decimals can be written as fractions? Well, there are two types. The first one, 5 over 2, gives us a decimal as 2.5. We call this a terminating decimal because the decimal ends. Also, we have fractions like 1/3, which give us what we call a repeating decimal. That little bar over the numbers tells us that that 3-3 combination is going to repeat forever. So it's going to be 0.333333333333 forever. So a terminating decimal or a repeating decimal can be written as a fraction, which makes it a rational number. So we can see these four number sets relate to each other, that the naturals fit into the wholes fit into the integers fit into the rationals, just like our geographic locations. Grayslake into Lake County into Illinois, Illinois into United States. Smaller to bigger fits. Bigger to smaller does not fit. Just remember that. So what about like the other countries, like Australia? Well, that's going to be our irrational numbers. These are numbers that cannot be written as fractions. So we know what kind of decimals and numbers can be written as fractions. So what kind of numbers cannot be written as a fraction? Well, any number that has a non-terminating, means it never ends, and non-repeating means we don't have that bar above. Any decimal like that is an irrational number. Pi is a very famous irrational number, 3.14159265 and so forth, on for a really long time, meaning forever. Also, whenever we start using radicals on numbers, we're going to get some irrational numbers. Now, not all radicals are going to be irrationals, but a lot of them will be. That decimal is never going to repeat, and it's never going to end, making it irrational. One thing to remember here is that if you're in Australia, you cannot be located in Grayslake, Lake County, Illinois, or the United States. It's a completely separate geographic location. And this number set is a completely separate number set than the previous 4. Now, if we put all of the number sets together, just like if we put all those geographic locations together, we get the real numbers, all the rational and irrational numbers. This is like planet Earth. It's all of the numbers that we're going to be working with here in algebra put together in one place. So let's kind of look at a little chart here to help us visualize how these number sets relate here. The natural numbers are the smallest number set, and they're inside the whole numbers. The whole numbers are inside the integers, and the integers are inside the rationals. So if you're a natural number, that means you're also going to be whole, integer, and rational. If you're an integer, though, you're only guaranteed to be rational. We can't go from bigger to smaller and guaranteed to be in those number sets. We also have the irrational numbers, which you can see have no connection with the previous 4 number sets there. That's like Australia. And then when we take all of these numbers combined, that is our real numbers. Now, I know I went through this really quick. If you need to pause, rewind, go back, fill in some things in the notes, please do so before we start to getting to some examples of applying these number sets here, our understanding of these number sets. So, what we want you to do now is look at the number and tell us where would this number be located, right? Which number sets would these numbers be a part of? 8, -5, 0, 7 over 2, -4.18 with that little bar, square root of 2, square root of 16. List all the number sets it belongs to, not just one, but you got to list all of them. So go ahead, pause the video, and give it a shot now. Okay, let's see how we did here. So we can see number 1 is every number set but irrational, natural, whole, integer, rational, real. It lives in Grayslake, it lives in Lake County, it lives in Illinois, it lives in the United States, and it lives on planet Earth. Number 2 is only an integer, irrational, and real because it's negative. 3 is a whole integer, rational, and real because it's 0. 7/2 is a fraction, so it's not going to be natural, whole, or integer. It's only going to be rational and real. -4.18 repeating, remember a repeating decimal can be written as a fraction, so that one is going to be rational and real. Now if you take the square root of 2 and you turn it into a decimal like using your calculator, you're going to see a list of decimals that don't end and don't repeat, meaning it's irrational. But if it's irrational, it's also real. Our last one, the square root of 16, is a radical. It's a square root, but when you put that in your calculator, you get the number 4. Just like number 1, that's natural, whole, integer, rational, and real. Couple things to notice here. 1, every number is part of the reals. You should always be including it in the reals. They all live on planet Earth. The other thing we should notice is that if a number is rational, it's not irrational. And if it's irrational, it's not rational. It can never be all of the number sets. Rational and irrational don't go together there. Okay, so let's answer some questions now based on looking at a number line here. You have 5 numbers, A, B, C, D, and E. We're not exactly sure what some of them are. Other ones we can see, they're at tick marks on our number line there. So answer the 4 questions. You might be using just one letter. You might be using all of them. But answer for all of the numbers that apply here with these 4 questions below. Ready? Pause the video now. Okay, let's see how you did here. Which number is the whole number? Well, that's C, D, and E. 0, 2, and what is that? 1, 2, 3, 4, 5, 6. E would be 6 there. Those would all be whole numbers. Which points would be an integer? Right? That'd be B, C, D, and E. A would not be an integer because it's in between the tick marks, making it a fraction or decimal. What number sets does point E belong to? Well, we said E is 6, so that would be natural, whole, integer, rational, and real. Which number sets does A belong to? Well, the answer is not enough information. We do know it's a real number, right? We know they're all real numbers, but we don't know whether A is a decimal that terminates, repeats, or doesn't do either of those. We can't determine if A is rational or real from the information we're given. So we have to say there's not enough information to know what all the number sets that A would belong to. Okay, guys, I know we went through this quick because there's a lot of information, but please, 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 again, if you got questions, please make sure you ask in class. Circle them, put a question mark, put a star by them, whatever you need to do in the notes to make sure you remember that when you come to class, you've got some questions. And that's the end. I really don't play Minecraft much, but from what I understand, it really doesn't end, which is why the question mark is there. We'll see you next time, guys.